ordinary least squares. So we have our data points. Now the question is that we're answering in this tutorial is, how do we know which of the sloped lines is the best one? Is it this one? Is it this one? Is it this one? Is it this one? Or is it this one? As we can see, there can be multiple sloped lines that we can draw through our data points. And how do we know which one is the best one, which is the best linear regression? And in fact, how do we even define the best one? So in order to answer those questions, we need to look at a method called the ordinary least squares method. And the way it works in a visual sense is we need to take our data points and project them vertically onto our linear regression line. Now we would need to do this for every single linear regression line that we're considering. But for simplicity's sake, in this tutorial, we're just going to do it with this line here in the middle. Now, for each pair of points, we have two values, yi and yi hat. So what are these values? Yi is the actual amount of potatoes, in our case, in our example, potatoes yielded from the farm when that specific amount of nitrogen fertilizer was used. So let's say 15 kilograms of nitrogen fertilizer were used and the farm yielded 2 tons of potatoes. Yi hat, on the other hand, is what this linear regression that we're considering, what it predicts the yield to be, or would have been. So in this case, let's say again, 15 kilograms of nitrogen were used, but the linear regression that we're looking at predicts that only 1.5 tons of potatoes would have been yielded from the farm. As you can see, there's a slight difference between the actual value, actual yield, and the predicted yield, and that's normal. It's never going to be perfectly, this line's never going to go perfectly through every single data point. That's simply impossible. But what we want to do is we want to find the best line, and it will be related to how small these differences are, as we can imagine. So let's have a look here. There's our yi and yi hat. The difference between them is called the residual. Here's our equation. And the best equation is such equation where such an equation where the parameters b0 and b1 are such that the sum of the squares of the residuals is minimized. And that's why it's called the ordinary least squares method. So we need to take all of these residuals, these differences. We need to square them for every single data point. And then we need to add up the sum. And whenever we find the smallest value, so for whichever regression line this value is going to be the smallest, that will be the best regression line. And that will guarantee that the line is going nicely through the data points, and it is the best line or the best linear regression to use for modeling our problem. So there you go. That's in a nutshell how the ordinary least squares method works. And I look forward to seeing you next time. Until then, enjoy machine learning.